40 minutes left of solid chemistry lecturing.
I don't like the lectures.
You move the button.
Yeah, there you go.
You're welcome, Chris. You're great.
In the hall.
All right. Shh. What do I do with these numbers here, Ryan? There's a big orange X right here. What does that mean? Multiply. Then I divide by, right, Will? Okay. And Garth, what's the right answer for number 17? Go ahead and tell me, please. Answer is D. It is 1.9 moles. All right. Letter D. Thank you, Garth. I want you to go sit in the back with the seniors. Go. Those are not seniors, so you sit in the back with them. Yes. Yes. All right. 18. I want you to sit with the not seniors. 18. Everyone say Dalton's law of partial pressures. All right. This is how it works. The total pressure is the sum of all the partial pressures. All right, Aaron Crankshaw, what is the total pressure in our system here? Number 18. 632 mmHg. You ran out of time.
You didn't give me time.
It's over. All right. Now, shh. Partial pressure of CO2. Thank you. Is 124.3. Garth, Sam, turn around. Partial pressure, Sam. What's the partial pressure of the nitrogen? All right, good. So I'm going to add that. Now, Casey, what's the partial pressure of the oxygen? The partial pressure of the oxygen. We don't know, do we? So that's the unknown variable. I'm going to call it x, and I want to solve for x. Everything here is added together. So I'm going to subtract, 124.3. I'm going to subtract the sum of these numbers right here. Okay? So 632 minus this is equal to number 18. The correct answer must be B. Yes. And something like that, right? Number 19. Now, this is important, number 19. There's a lot to learn on number 19, even though it's not a math problem, Chris. Shh. Sometimes the math problem, the non-math problems can be more challenging. Covalent compounds. What are covalent compounds made of? Metals? Non-metals? What? Only. Very good. Garth, Chris. Only non-metals. Now, what do you think the question might be on the test? If it may not be about covalent. What's another type of bond? Ionic. Thank you, Hunter. All right, this is metal plus non-metal. There's also metallic bonding, made of only metal. Okay? All right, now, right here. What's wrong with this one? This isn't even a compound. This is a single element, so you don't have any kind of covalent bonding. What is this right here? Salt. Put that in the garbage. It's NaCl, which is ionic.
Why did that one not have that separate?
Because you know that one. This is metal, non-metal, so that's also ionic. What is this one, kids? That is CHO, carbohydrate. You learned that in biology, and that is a covalent compound. If you see glucose, sucrose, lactose, galactose, fructose, those are all carbohydrates.
So wait, so carbon is not a non-metal?
Carbon is a non-metal.
So isn't that, covalent?
Yes.
So how come you put sucrose?
This is a group of non-metals, so it's covalent.
So graphite is a non-metal too.
But that's
it's a
an
group,
element.
it's not a group.
That's an element, so there's no bonding, no covalent bonding. All right? Shh. This right here is the question I told you we were going to get to that has to do with density. All right. Shh. Now, look at this. Solid, liquid, gas. Now, we know that for water it's different, but generally solid, liquid, gas, what has the lowest density? Solid, liquid, or gas? Gas, right? So, what are your two choices? The two gases. All right. Now, look at their molar masses. What's the molar mass of this? 18 grams per mole. And this is Br2, which is 80 times 2. I'm getting that from the periodic table. All right. Which one for a mole of gas is going to be much heavier? Bromine is much heavier, okay? So it would be much denser. So right here, the correct answer is water gas. But let me prepare you for something, guys. The opposite question of what has the highest density is going to be harder. Garth, I advise that you pay attention to this. Katie, what do you think is going to have the highest density of all these? This is important. If you're want to be successful, let's talk about what has the highest density. All right, should be the solids except for water. If we're talking about liquid water, then we're going to have higher density than solid, because we know that ice floats from that picture we did earlier. So now let's see. Out of these two, what has the higher density?
H2O liquid form.
The liquid has a higher density because remember it sinks to the bottom of a glass of ice water. All right. Now this also might have a higher density because it's a liquid. Which of these two is going to have a higher density? D. Very good. Katie, very good. This has the higher density of these. Shut the door, please. Stay inside, Jay. Yes. Number 21. Katie, you might want to know the answer to this question. Why? Oh, also, we need to get set up on an Emoto account today. Why is ice less dense than liquid water? We didn't discuss this.
Liquid water floats to the bottom when ice is in them.
But that's not one of the answer choices. Which molecules are farther apart? Liquid or ice?
Liquid.
Ice molecules are farther apart. Remember this right here? Ice gets itself... Casey, you're distracting 4 people. Maybe 5 back there, including me. 6 people. I'm not concentrating. If I'm not concentrating, nobody's learning. Shh. Don't sit in my chair. No. No, you can't sit in my chair. This is solid. Right here. All right. Now, solid water molecules space themselves out very far apart, Victoria. The liquid molecules get closer together. They squish in much closer together. All right.
So it's
Why do they do that? This right here likes to form in this crystalline pattern, and that crystalline pattern calls for a very structured, lined up arrangement, and because of the triangular shape, if they want to get lined up, they're in this arrangement that creates a lot of kind of empty gaps and empty holes. But when they're liquid, they're more free to move around, so they kind of just collapse back into those empty spaces. The molecules do. Because of the shape and the hydrogen bonding, okay?
that retro music.
Remember, we were still recording.
I turned it off.
No, we're still recording.
He's saying that your phone, you hit record on your phone.
All right, we're recording again.
Shut up.
All right. All right.
Thank God.
Correct answer is not this. Liquid water molecules are close together. A, the molecules in liquid water crowd together more compactly in the ice. Isn't that what I was telling Hunter? Yes. 21, a substance whose water solution conducts a current. Let's go with Mr. Chan Lee. 22. Chris Albert. Chan just fell apart on us.
Don't listen to Chris, he might be wrong.
Say electrolyte. Electrolyte. All right, doesn't that make sense, Chan? Conducts a current, electrolyte. Sounds like electricity to you, doesn't it? Okay. All right.
Which mouth?
23. The substance right here in the phase diagram is at 1.2 atmospheres and 100 degrees Celsius. So we're somewhere around here, right, Dwayne? This is solid, this is liquid, this is gas. So now, uh-oh.
Hey, Josh.
Josh, go in the back, please. Go in the back. What state change occurs when the pressure changes to 0.8? Liquid to gas. Brian, what's that called? Liquid to gas. Don't put that on my chair, please. Which one of these choices? Look at the choices. Look at the choices.
Sublimate.
23, 23, 23. Boiling.
Gas? How is that sublimation?
This sublimation, Chris, your voice, I can hear it too much and it's distracting me. I can't concentrate.
Yes, it is. It's solid to it. Gas to it. Okay, so solid to it. Gas.
Shh. All right. What state of matter will this substance be in at a temperature of 50 degrees Celsius and a pressure of 0.8 atmospheres? 50 Celsius, 1.8 atmospheres, somewhere around here, right guys? So let's go with Taylor Campbell. What state of matter is that? If we're right here, young lady. Look at this mistake I made. Sublimation is solid to gas. Did everyone see that mistake I made? Let's go tickets. We're not doing tickets. Go to the other room. Y'all see what mistake I made?
Yes, thank you, Chris, for pointing that out.
I'll be there in a minute. I'll be there in a minute.
Now I can't wrong.
Sit down. No, go to your seat, Chris. All right. Number 25. Which is the point at which the substance will melt at normal atmospheric pressure? All right, guys. Which is your melting point line? Is it yellow? Is it purple? Or is it black? No. Which one is melting? Solid gas, solid liquid, liquid gas. What is melting?
Solid liquid.
Solid liquid. It's the purple. Thank you, Hunter. It's the purple line. which is the point at which the substance will melt at normal? Do you know, y'all know what normal means? It means 1 atmosphere. Which choices can I automatically eliminate?
Isn't it 85?
Which choices can I eliminate? Ryan O'Neill, which of these choices doesn't have 1 atmosphere listed? A and B are wrong. Okay, I'm in the middle of taping a show. All right, so it's got to be one of these two.
These the closest to.
At 1 atmosphere, where am I going to hit solid liquid? Somewhere between 70 and 80.
So 88 or 84.
70 and 80, it must be 84, right? You go get on it. Where's Cooper? You know what? Does this answer look right to you? Should be close to 80. Which of these choices is the closest to 80, guys? Is that the right answer on your worksheet? Okay. It's really not quite 80, is it? But anyway, is it? Okay. 26, triple point. Let's see. Jasmine, where is the triple point on this thing going to be? Is it the point where all 3 come together? Yes. All right. So, now, what's the triple point? We have to find the temperature and the pressure, right, Chris?
Yes.
Where is it? It's right under 1 atmosphere, and it's at 86?
So 88.
88. Well, I said 86, but when I look at my answer choices, do I see that this must be the right answer, correct? Okay. Yeah, when you're reading these graphs and you're estimating in between these little points that are hard to see, you're going to find the answer that matches best with what you got. Now, if it's way off, you might need to redo it, okay? All right. Shh, we're doing good, so let's keep going. Number 27. Yep.